Hello and welcome back to my bench. Well, today we want to speak about the final test after we have set our bias current at the power amplifier of our radio. And therefore, before the radio will leave our lab, we should perform a third order intermodulation test, because this is really crucial when we are not within the specs. But okay, one step after the other. Well, recently I replaced the final stage in this nice old FT747. So this is still a radio which is very much used in the field, and so yeah, this kind of radio is sometimes on my bench, and well, this one has gotten a new final, not final, sorry, a preamp stage, so the driver stage, and well, I have done the bias setting, and now to be sure that everything is okay, we will perform yeah, let me call it final test, because it is leaving the lab to be sure that everything is fine. Okay, and as we are performing a transmitter intermodulation test, we need, of course, our signalant, which we have had looked into in our last episode. And there I mentioned already that this signal generator does have two independent outputs, signal outputs. So that is what we need, because we need for our test a double tone, and therefore I need both outputs, and we need different frequencies where we feed our transmitter with, and therefore we have here this little RF combiner where we feed in this both frequencies. In our case it is on one channel, it is 400 Hertz, which you might can read here, and on the second channel we are feeding in 2 kilohertz, and these two frequencies gets combined here in the combiner, and then the output is here, yeah, both signals together, and these both signals will then go here to our microphone jack, and we feed in the double tone right here. The radio is set to 14 megahertz, and well, it is set to upper sideband, so we expect the carriers, the tones, right beside our set frequency here on the radio. Well, before we dive now too deep in our measuring, we should speak a little bit about what third order transmitter intermodulation is, and therefore we have already seen at our signal generator that we are feeding in audio frequencies with 400 Hertz, and the second one with 2 kilohertz. So the delta between these both frequencies is 1.6 kilohertz, but this will come a bit later. And I have already said that we dialed on our radio 14 megahertz in, and we set our radio to upper sideband. So we expect our tones right beneath our carrier. But remember, single sideband, our carrier is suppressed, so it is not really seen on the spectrum analyzer, because we have reduced it in the balance modulator as much as we can, so it is somewhat around minus 60 dB. So therefore we only see our tones on 14.0004 megahertz, which represents our 400 hertz audio tone, and we see our 14.002 megahertz, which represents our 2 kilohertz audio tone. And on the spectrum analyzer we will see this both tones. So these are then the let me call it carriers, the tones. And well, if we are feeding an amplifier with a double tone, we always will have intermodulation products, and we are interested in the third order intermodulation products. And on the left hand side and on the right hand side of our feeded tones, there we will find our intermodulation products. And what we are looking for is that the delta from this let me call it DBC for DB carrier down to this should at minimum 20 dB, and so that is the minimum what a shortwave radio should reach. And good shortwave radios, or in general good radios, are able to show intermodulation product of 30 up to 40 dB under the carrier. So let me call this here the carrier, and the intermodulation product is under the carrier, so that is of course what we expect. And as I said, the minimum should be 20. And well, this old radio, so let me have a look into the specs. So these are the specs, and we find here, here, third order intermodulation distortion better than 20 minus 25 dB at 100 watt PEP. Well, this is the second challenge, but well, maybe this is something for a separate video. So what is PEP, what is average, and yeah, that is a little bit complicated. So do not believe what you read on your power meter. So that is not PEP, so that is mostly average, but also average is a little bit challenging. So, well, this is definitely something for a different video. So let us leave it at the point that we feed in 100 watt PEP, and we want to see if the third order intermodulation is minus 25 dB. And that means that of course you know, the third order intermodulation has to be 25 dB under this carrier. Well, and how do we calculate it? Well, the intermodulation product third order is calculated by F2, which is this one, 2 times F2 minus F1, which means 2 times 14,002 megahertz minus 14.0004 megahertz, and this together is 14.0036, and there we expect our intermodulation product, and the delta between our F2 and the intermodulation product is again 1.6 kilohertz. You can simply see it if you do the math between these both figures, and that again is exactly the delta frequency between our audio frequencies which we feed in to the microphone jack. So that is a little bit the theory about the third order intermodulation product, and well, as better this figure is, so as bigger the distance, so as deeper it is under the carrier, as better is the purity of the transmitted signal. And the minimum what we want to see is with this old radio minus 25 dB under our carrier tone. Okay, you can see now already the spectrum analyzer screen, and now I set the radio to transmit, and our both tones are in, and you already can see them here. So this is our 400 Hertz, and this is our 2 kilohertz tone, but now we are on the RF side. Remember, we are transmitting these audio tones on 14 megahertz. So when I now put on the peak right here, you see that the marker is reporting 14.00037, so that is very close to our 14.00004, which represents our 400 kilohertz in audio frequency. This is a normal measuring fold, because it is a little bit difficult to read so many digits behind the point. So this is really a little bit difficult, but you see now we are in RF. We are now on the RF side, and when I look to our second tone, you see this is our 2 kilohertz audio tone, which is now on RF frequency. Okay, so we know our both frequencies are there, so the double tone is definitely seen here on our screen. Okay, and then let's check if our calculation was right. So therefore let's go to this product, which is of course our intermodulation product third order. And remember, we calculated 14.0036 as the intermodulation product on the right hand side, and have a look. So 14.0036, so that is close enough. So this must be our third order intermodulation product. And as I explained before, this intermodulation product have to be for this radio 25 dB under our carrier tone. And therefore, let's go left with our marker, and now we can switch on our delta marker. This is really a very handy feature, because now I can move our delta marker exactly to 1.6 kilohertz, because as we know, we are 1.6 kilohertz away from our carrier. So that is what we have seen on our piece of paper, where I explained it a little bit. And now what we can see is that we are 26 dB under the carrier. So that means we are matching exactly the requirements of our technical data sheet. So that is what the manufacturer said when he has put this radio into production. And of course we have exactly the same when we go to our left carrier, which represents our 400 Hertz audio frequency on RF. So that is clear. So we have here again our third order intermodulation product, and now we can do exactly the same. So we go on delta marker, and we move our marker exactly to 1.6 kilohertz. So there we know is our third order intermodulation product. And what you can see here, we are at minus 26 dB. So again, we are matching the requirements of the manufacturer, who is telling us that the third order intermodulation should be better than -25 dB at 100 watt PEP. And again, be careful with PEP. So this is, as I already mentioned, a second story. So I have set the radio in advance to exactly 100 watt PEP, and yeah, when this setting has been done, then you can perform your third order TX intermodulation product. Well, and to summarize, what can we say? The repair of the driver stage and the bias setting is okay, so there is nothing to complain. We are now sure that our radio is meeting the requirements. This is very important, so that we do not produce any distortions on the radio band. And you know, if these intermodulation products are not good, then we produce splatter on the radio bands and such. So yeah, this is very important to check and to be sure on when a radio which had a repair somewhere in the final stage, then you always should check if the intermodulation products are okay. Well, not everybody have a spectrum analyzer at home, but you can do a very similar check with your scope. And what you see here on the scope are the pattern as it looks like when your signal is basically working and when it is okay. Okay, so well, once again, for your double tone you need such a combiner, and you need your both outputs from your signal generator, and then you are able to perform this intermodulation test. So that's it for today. I hope that was again a little bit informative, and yeah, if you like it, please give me a thumb up for this video, and if you do not have subscribed yet, please subscribe to my channel. Okay, thank you and bye.